Welcome to the Hill to Hill Bridge Project virtual public meeting. During this presentation, you will learn about how PennDOT is progressing a project to improve the Hill to Hill Bridge and the surrounding roadway network. We will discuss the alternatives analysis which is currently being prepared, review the many sensitive resources in the project study limits and their impact on the project's design. We will also review the thought process behind and discuss the alternative we are proposing to progress into preliminary engineering and talk about the next steps for this project. Most importantly, this meeting serves as an opportunity to solicit input and feedback from you that will serve to shape the project as it moves into preliminary engineering phase of design. As you watch and listen to this presentation, please pause at any point and fill in the comment and feedback form located to the right of this video. Receiving input from the public plays a critical role in the transportation project delivery process and will help inform engineering choices made as design progresses for the Hill to Hill Bridge. The Hill to Hill Bridge is nearly 100 years old, and repairs are needed to continue to maintain this river crossing. The bridge carries more than 55,000 vehicles per day and is a critical transportation feature for both the region and the city of Bethlehem. Specifically related to the city, it serves as an important link for pedestrians walking from the north to the south side of Bethlehem, especially during festivals and community events. Why do we need this project? The structure is in need of repair to extend its life. In addition, there are significant congestion-related traffic issues surrounding the bridge that, at times, severely impact mobility in the area. Due to its size, complexity, and cost of working on the bridge, significant advanced planning is needed. To determine how to address the issues, the department initiated an alternatives analysis study for the bridge. Feedback from this meeting will be considered as part of the alternatives analysis and will be considered as design advances. Your feedback helps inform design decisions as the project progresses through and into preliminary engineering. Next, we will look at what goes into an alternatives analysis. The goals of the alternatives analysis for the Hill to Hill Bridge are to identify ways to address the deteriorating condition of the bridge, identify the resources which are present and surrounding the structure, look outside the bridge at issues such as traffic congestion, and collect input from stakeholders in the community. There are 4 key phases of the alternatives analysis. 1. To define the study area. 2. To conduct data collection and analysis. 3. To identify the purpose and needs. And finally, 4. To develop alternatives and compare how well these alternatives meet the needs of the project. We will walk through each one of these steps in the alternatives analysis process next, but notice that at the bottom of the slide is continual stakeholder input and public engagement. Key to the success of the project is the local perspective of the issues that are present. This perspective can help shape the range and scope of the alternatives which are considered, identify project needs, and develop project goals. The first step in the alternatives analysis is to define our problem area. We call this the project study area. Generally, this starts as the area that represents the combined footprint of all potential alternatives being considered. For the Hill to Hill project, this area stretches out along SR 378 to include the West Broad Street overpass, the Main Street Ramp Bridge, the Spring Street Ramp Bridge, the hub, which is defined as where SR 378, Main Street, and Spring Street come together, the 2nd Street ramp and Riverside Drive, and the intersection of West 3rd Street and 378. The study area does not indicate the limits of disturbance, nor does it infer that all features within its boundaries will be worked on. With the study area defined, the project team can begin to initiate studies, conduct inspections, collect data, hear stakeholder input, and assess existing design criteria. This process has been ongoing for the Hill to Hill alternatives analysis. Here are the highlights of the data collection and analyses which have been conducted so far. Supplemental inspection. A detailed field inspection of the existing Hill to Hill Bridge was conducted. Recently, additional inspection efforts were completed for the Main Street and Spring Street ramps. These inspections help us to define the structural issues present and helps to develop structure-related needs for the project. Stakeholder input. Early input was received from several stakeholders and consulting parties from the surrounding community. This early engagement with project stakeholders is key to understanding the issues facing the community today and the potential impacts of construction. Traffic and pedestrian studies. While this is the Hill-to-Hill Bridge project, there are significant traffic-related issues surrounding the structure. To understand these issues, traffic, pedestrian, and bicycle counts were conducted. Average wait time, referred to as queue time, and travel time were evaluated. Turning movements were looked at, and levels of service, which help us define how congested a roadway is in the existing condition, were identified. Why is all of this important? These studies help us to set up the baseline for how traffic flows through and around the bridge today. We are then able to develop how traffic will change in the future based on anticipated population growth, transportation trends, and other known projects in the area. From here, we are able to evaluate each of the alternatives under consideration to see if they improve upon these conditions. Design criteria assessments. Design criteria is developed by federal and state transportation organizations and agencies, such as the Federal Highway Administration and the American Association of State Highway and Transportation Officials. Design criteria outlines the current standard widths, grades, and features of highway and bridge design. During the preliminary phases of the project development, engineers check existing conditions to determine if they comply with modern design criteria. For example, older structures tend to have been built with narrower widths. While the width may have been appropriate for vehicles that used these bridges decades ago, they may not meet current standards for lane widths. As part of the data collection and analysis phase of the project, a list of site constraints is developed. Constraints may need to be avoided or the impact to them minimized. For example, there are numerous utilities present which use the existing Hill-to-Hill bridge structure to cross the Lehigh River, pass under the approaches to the bridge, or are located within the study limits. These utility lines and the potential effects related to construction must be carefully considered as alternatives are assessed. While temporarily shutting down an electric line to facilitate construction is possible in some circumstances, it comes at a cost to the project schedule and impacts the utility company and their customers. Other examples of constraints include natural resources, railroads, public parks, and recreational features in private property. The following slides walk through some of the site constraints which exist for the Hill-to-Hill Bridge project. Pictured on this slide are the major utilities within the project area. While coordination with each potentially impacted utility is required, the most impactful of utilities are those that cross the bridge using conduits located underneath of the existing sidewalks. These include fiber optic, cable, and telephone lines. The design team will coordinate with these utilities to determine if temporary interruptions are acceptable, and if not, how the lines can be preserved and temporarily supported throughout construction. Permanent relocation of utility lines may also be assessed. However, given the need to cross the Lehigh River, this is unlikely. There are 4 primary Norfolk Southern rail lines throughout the project study area, which run underneath of the existing Hill-to-Hill Bridge on the north and south sides of the Lehigh River. There are minimum horizontal and vertical clearances for these lines, which must be considered for alterations to the existing structure and for any new structure which may cross over the line. These represent vertical constraints on the project and result in direct impacts to how alternatives tie back into the approach roadway on either side of the structure. Having to provide additional vertical clearance for a new structure, for example, could result in significant work to tie the new structure back down into the existing approach roadways. Another consideration is the presence of trails within the project study area. Enhancing bicycle connectivity is a regional and national goal that the Hill-to-Hill Bridge project must consider. Recreational features such as the D&L Canal Trail and the planned South Bethlehem Greenway are located near the project, and improving connectivity for bicyclists and pedestrians was brought up early on by project stakeholders as an important local consideration. There are also a number of environmental constraints present within the project study area, including historic resources shown in yellow, recreational resources shown in green, and special protected recreational lands shown in purple. Additionally, there's a levee system along the south bank of the Lehigh River. Generally, the governing laws and regulations which protect these resources require that transportation agencies look to avoid impact, if possible, to these resources. If impacts are unavoidable, they must be minimized and mitigated. A key component of the alternatives analysis is evaluating each alternative's impact to these resources and determining if the purpose and need of the project could be accomplished through an alternative which avoids or lessens impacts. As touched on in the previous slide, adverse effects to historic and archaeological resources must be avoided if possible. If adverse effects are unavoidable, agencies are required to minimize their impact to the extent possible and develop mitigation measures to offset these impacts. As part of this project's initial studies, research was conducted into the surrounding historic resources to determine which are eligible for inclusion on the National Register of Historic Places. Present within the study limits are individual resources such as the Nativity Church and Lehigh Canal, and historic districts such as the Central Bethlehem and South Bethlehem Downtown Historic Districts, which are comprised of dozens of contributing resources. While many of these resources intersect the project area and the study limits, the two resources which are most likely to be impacted by several of the alternatives being studied are the Hill-to-Hill Bridge itself and the Fritz Fuel property. These are detailed further on the next slide. During the early studies for this project, the Hill-to-Hill Bridge was evaluated to determine its eligibility for inclusion on the National Register of Historic Places. It was found eligible with its character-defining features being the closed spandrel arches, decorative concrete elements, and the Hudson truss spans. Alterations to these components of the bridge may result in an impact to its historic designation. In addition to its eligibility as an individual resource, the Hill-to-Hill Bridge is a contributing resource to the Central Bethlehem and Fountain Hill historic districts. The early studies also determined that the Fritz Fuel Company time and temperature sign is eligible for the National Register of Historic Places. The coal bins on which the sign sits today had already been determined to be contributing resources to the Central Bethlehem Historic District in 1986. Additional information on historic resources for the project can be found at path.penndot.gov. Next, we will talk about purpose and need, its role in transportation projects, and its importance when assessing alternatives. The purpose and need statement is the foundation on which transportation projects are built. The purpose is an overarching statement of what the project is intended to accomplish, while the needs are specific problems or deficiencies that the project seeks to address. Together, these form the purpose and need statement. It's important to note that the purpose and need statement does not dictate an outcome or identify a solution. It's a problem statement that is used as the bar to measure all alternatives by. The data collection, analysis, stakeholder input, and preliminary studies which have been conducted up until this point help define the project's purpose and needs. The purpose and needs statement is developed in close coordination with the Federal Highway Administration, which, due to the anticipated use of federal funds for construction, are the lead federal agency for this project. Alternatives which cannot meet the purpose and needs are dismissed from further consideration. For the Hill-to-Hill Bridge, the purpose of the project is to provide a long-term safe and efficient crossing which facilitates vehicular, rail, bicycle, and pedestrian flow, while also accommodating the current and future growth of the city and generally maintaining or improving upon network congestion levels compared to future no-build conditions. Based on initial studies and stakeholder input, 4 core needs have been identified. These include safety, congestion, structure condition, and mobility. For the purposes of this presentation, these core needs are identified using the symbols which will be located at the bottom of the slide. You will see these symbols again later when we discuss how each alternative considered measures up against these needs. Safety. A primary need for the project is to provide improvements to safety. The majority of the crashes observed are rear-end collisions which can be attributed to congestion. These types of crashes are observed on the 2nd Street ramp and heading southbound across the bridge near the intersection with the 2nd Street ramp. Based on the types of crashes observed, a primary factor is likely the lack of sufficient stacking length for vehicles. Additionally, there is insufficient turning radius on the south end of the bridge for southbound vehicles turning right onto Brighton Street and for vehicles turning onto the northbound lanes across the bridge from the 2nd Street ramp. Congestion. The Hill-to-Hill Bridge serves as a vital link for the city and is a regional transportation route. Based on initial studies conducted, over 55,000 vehicles per day on average use the bridge, with 6% of those being trucks. During the AM and PM peak hours for travel, significant congestion is regularly observed. Based on traffic studies conducted for the project, which simulate what traffic will be like in the years to come, congestion is not forecasted to improve. The major causes of congestion identified in the project limits occur on the south side of the Lehigh River and include the following: lack of capacity for southbound traffic traveling on 378 at 3rd Street, lack of queue storage for northbound traffic on 378 at the 2nd Street ramp, and lack of capacity for southbound left turns from 378 to the 2nd Street ramp and northbound right turns from the 2nd Street ramp to 378. The ability of each alternative to improve the existing congested conditions is assessed as part of the alternatives analysis. Structure condition. Several elements of the existing Hill-to-Hill Bridge, whether by original design or through wear and tear over the years, warrant action to ensure that the structure does not deteriorate any further. Based on recent inspections, the main repairs required to extend the life of the bridge include improving the drainage system, repairing deteriorated concrete throughout the bridge, and repairing the steel trusses. The ability of each of the alternatives to address these observed deficiencies is assessed as part of the alternatives analysis. Mobility and modal interrelationships. SR 378 connects the north and south sides of the city of Bethlehem, providing a critical link for residents, businesses, and services. Not only does it serve as an important role in connecting the north and south sides of Bethlehem, it also is critically important for many festivals and activities which take place throughout the year, including Music Fest. Initial studies have indicated that nearly 300 to 350 pedestrians and 60 to 100 bicyclists use the bridge each day. During events such as Music Fest, up to 150 to 250 pedestrians use the bridge per hour. Trails, both existing and planned, also are anticipated to result in increased usage of the bridge by pedestrians and bicyclists. Additionally, the bridge serves as a connection for public transit. However, based on initial coordination with LANTA, buses currently do not route over the bridge due to unreliable travel times. Maintaining and improving upon these important interconnections with a variety of modes of transportation is a core need for this project. In addition to the project needs, project goals can be developed. Goals are defined as secondary objectives and, unlike project needs, cannot be used to dismiss alternatives. These are the nice-to-haves, which may come from stakeholder coordination or local requests. For the Hill-to-Hill Bridge project, 6 main goals were developed and include the following: maintain 4 lanes of traffic during peak hours of bridge usage, communicate roadway typology change from highway to city grid, minimize impacts to cultural resources, improve 2nd Street connection, preserve Main Street ramp bridge, and design not to preclude future improvement, For example, plans by the city, railroad, trails, PennDOT, etc. The table on this slide provides a summary of the core alternatives investigated during this initial phase of alternatives development. Green arrows indicate the alternative moved forward into a more detailed analysis, while red arrows with a block at the end of them indicate that the alternative was dismissed. As you will see in our discussion today, a key challenge for the alternatives is completing the work while limiting impact to the surrounding transportation network. With SR 378's high traffic volume and a lack of suitable crossings which could handle this number of vehicles, maintaining access across the bridge for traffic during construction is a key issue. For example, Alternative 2 included the full rehabilitation of the existing structure, including the removal and replacement of fill material which resides underneath of the pavement and on top of the existing concrete arches. To accomplish this type of work, a significant amount of time and access is needed, resulting in long duration shutdowns of the hill-to-hill bridge. Even with this structure work, this alternative would still not address the safety and congestion needs. For these reasons, this alternative was dismissed from detailed analysis. Alternative 3A was dismissed as it would include the removal of the southern truss from the existing bridge, resulting in an impact to the bridge's historic character, and because of another alternative developed, 3B, which accomplishes a similar level of benefit with a lesser impact by preserving the trusses. Other alternatives which were considered but ultimately dismissed include Alternative 4, rehabilitation of the existing bridge with widening, and Alternative 5A, which would remove the existing bridge and replace it entirely with a new structure. Both of these alternatives result in more significant impacts to historic resources compared to other alternatives that meet the project needs. Thus, these alternatives were dismissed from detailed analysis. For each of the alternatives which progress to a detailed analysis, we will walk through their scope of work and describe how each meets or does not meet the project needs. Before we review the first alternative, let's take a brief moment to review how each alternative's ability to meet the purpose and needs will be presented. As you look at the bottom of the page, you'll notice three columns. These columns represent how the purpose and needs are being met, whether the alternative retains the existing trusses, and what additional resources are impacted by the alternative. The additional resource column does not include all possible resource impacts, but is used to represent the major impacts associated with the alternative. As a reminder, the safety need is represented by the winding road, congestion by 3 cars, structure condition by the bridge symbol, and mobility by the bicycle symbol. A green check mark above the need symbol indicates that the base need has been met. Alternatives which fully meet the needs receive a green check and the full symbol, while alternatives that make improvements and therefore meet the minimum base need use a partial symbol. The first alternative, the no-build alternative, typically receives the most questions during public and stakeholder engagement as people wonder why this do-nothing alternative is even being considered. This alternative includes no physical work on the structure or approaches, and this alternative serves as a baseline by which other alternatives can be assessed. For example, the design team may investigate how traffic patterns are anticipated to evolve in the future if the conditions remain as they are today. This is a helpful tool in understanding how much each alternative is anticipated to improve on the existing conditions of today, as well as the conditions 10 to 20 years from now. As you can see at the bottom of the slide, the no-build alternative does not meet the safety, congestion, or structural needs. While it does maintain access for pedestrians and bicyclists, and therefore meets the minimum base mobility need, there is room to improve the riding experience and connectivity for bicyclists, so a partial bicycle symbol is shown. There are no additional resource impacts for the no-build alternative. However, by doing nothing to address the condition of the existing bridge, it will continue to degrade. Components which are significant to its designation as a historic resource will also degrade and may eventually result in effect to its historic status. Alternative 2E represents the state of good repair level rehabilitation of the existing structure. The goal of this alternative is to extend the structure's service life. This alternative maintains the existing structure and its geometry and includes preventative level repairs, improvements to drainage, roadway surface repair, sidewalk and pedestrian railing repair, and improvements to lighting. So how does this alternative meet the needs of the project? For the safety need, alternative 2E provides the minimum required lane widths due to there being no widening. However, this alternative does not address the insufficient stacking length or limited turning radius at the south end of the bridge. Therefore, alternative 2E does not meet the safety need and it receives a red X above the safety need symbol. For the congestion need, alternative 2E does not address the queuing problem for left turns onto the 2nd Street ramp. Therefore, this alternative does not meet the congestion need. For the structure need, this alternative addresses the basic deteriorated features observed as part of the detailed inspection. It would include repairs to the existing trusses and structural repairs at localized areas which are easily accessible. The existing roadway would receive spot repairs and a concrete overlay. While these surface level repairs are sufficient to achieve the core structure need, they do not address the underlying issues which cause deterioration of the bridge deck. For these reasons, alternative 2E meets the minimum basic structural need since it improves upon the structure condition. Therefore, it receives a partial symbol. Regarding the mobility need, alternative 2E maintains existing access for pedestrians and bicyclists, but it does not improve connections to adjoining trails or improve access on and off of the bridge. Therefore, it accomplishes the minimum basic mobility need since mobility is improved. Given the limited scope of work on the existing bridge, the north and south trusses would be maintained, and there are no additional anticipated resource impacts. As was seen with alternative 2E, the safety and congestion needs were not met since additional width on the bridge is needed at the 2nd Street intersection to reduce congestion. Alternative 3B iterates on 2E by including the same level of rehabilitation scope while adding a new parallel structure on the south end of the existing bridge to provide additional width. This results in a balanced approach between accomplishing the needs of the project and minimizing the impact of the surrounding constraints, properties, and resources. The new eastern structure would be constructed to support 2 northbound travel lanes and a sidewalk. The new structure would taper back and tie into the existing structure just before the northern truss. This allows both the southern and northern trusses to be maintained under this alternative. Looking at the needs of the project, we first will review the safety need. Similar to alternative 2E, alternative 3B maintains the minimum required lane widths across the existing structure and adds additional shoulder width on the southern end to address the existing substandard width. The turning radii from the 2nd Street ramp to the northbound travel lane on the bridge is improved by the parallel structure on the southern end. However, the movement from the southbound travel lane to Brighton Street is not improved. The northern portion of the bridge maintains its existing section. This alternative addresses the insufficient stacking length and improves the 2nd Street ramp turning radii at the south end of the bridge. Therefore, it meets the minimum basic safety need. Regarding the congestion need, this alternative improves upon 2E by adding an additional left turn movement onto the 2nd Street ramp. A right turn lane to westbound 3rd Street is also added under this alternative. Based on our preliminary traffic analyses, these are the most impactful ways to address the congestion need, and so this alternative meets the congestion need. Alternative 3B retains the same rehabilitation scope as 2E, which improves the structure condition. Therefore, it too meets the minimum basic structural need. Regarding the mobility need, Alternative 3B provides a 6-foot sidewalk along the new parallel ramp structure, which can be used by pedestrians and bicyclists who choose to walk their bikes across the bridge. While this is an improvement to access compared to 2E, it does not carry a mixed-use trail across the bridge. This alternative, therefore, meets the minimum basic mobility need. Both the south side and north side trusses are maintained in this alternative. However, Due to the larger footprint of this alternative and the new abutments and piers necessary to carry the new structure, this alternative results in impacts to the Army Corps of Engineers levee, Sand Island Park, and the Lehigh River. Additionally, the new parallel structure will alter the overall appearance of the Hill-to-Hill Bridge, as the new structure will be constructed in front of the Hill-to-Hill Bridge's concrete arches and southern truss. While the design of the new structure can be done to minimize visual impact to the extent possible, this impact would need to be further assessed as part of the design process. Alternative 5B iterates on 3B by extending the new structure proposed under 3B for the full length of the existing bridge. The new structure will be constructed to carry 2 lanes of northbound traffic, full shoulders, and a widened sidewalk supporting a mixed-use trail. The existing structure would remain, and the lane arrangement would be revised to carry 3 lanes of southbound traffic with narrow shoulders. The scope of repairs to the existing structure would be limited to the rehabilitation described under Alternative 2E. However, the additional width provided by the new parallel structure would allow for all traffic to be diverted off of the existing structure should additional work be required on the Hill-to-Hill Bridge in the future. The new structure allows for the carrying of a 10-foot mixed-use trail capable of handling both pedestrians and bicyclists completely across the river and onto the Main Street ramp. Regarding the safety need, Alternative 5B provides sufficient width to provide adequate travel lanes and shoulders for the length of the new parallel structure, which helps to reduce the stacking length. However, there is not enough width to provide for full 4-foot shoulders due to the restrictions in width caused by the existing trusses. Only 2-foot wide shoulders can be provided as a result of this restriction in width. The turning radii is also improved on the northbound roadway at the southern end. Overall, this is an improvement compared to Alternative 3B, which only improves the extra width up to the northern truss. For the congestion need, Alternative 5B is similar to 3B in that it provides for 2 left turn movements onto the 2nd Street ramp. Through and right turn movements at the intersection of 3rd Street are also provided under this alternative. An additional queuing length is provided. For the structure need, Alternative 5B continues with providing the same scope of rehabilitation as seen in 2E and 3B. Finally, 5B meets the mobility need to the fullest extent by improving bicycle connectivity and access compared to 3B. This is accomplished by providing a mixed-use trail across the entire length of the structure. While Alternative 5B has distinct advantages over the other alternatives considered related to the project needs, it comes at a cost. Alternative 5B is the most impactful to adjacent resources, properties, and historic features. The Fritsch fuel sign and silos would be removed to construct the new parallel structure, resulting in a direct impact to this resource and the Central Bethlehem Historic District. More significant acquisition of land from the Lehigh Valley Railroad Station would also be required, and the effect to this historic resource would need to be carefully evaluated during design. Additionally, new piers will be placed within the Lehigh River, Army Corps levee, and Sand Island Park. This alternative also results in the greatest level of impact to private property and has the greatest potential to affect the existing Hill-to-Hill Bridge's visual appearance, both due to the new structure spanning the full length of the existing Hill-to-Hill Bridge, and also because on the north side, portions of the existing arches would need to be filled in and retaining walls constructed to tie the new structure back onto SR 378. This alternative also has the greatest potential to impact archaeological resources due to its large footprint, although additional studies would be required during design to determine the potential presence of these archaeological resources. In addition to the main alternatives which are focused around the bridge itself, other off-bridge improvements are being evaluated as part of the alternatives analysis. For this assessment, we focused on the adjoining 2nd Street, Main Street, and Spring Street ramp. As part of the early discussions with stakeholders, improving access to the 2nd Street ramp and SR 378 is being investigated. We will discuss our findings for this ramp on the next slide. The Main Street ramp will be impacted by several of the alternatives under consideration, and preventative maintenance level repairs are being looked at for this ramp structure. Finally, the Spring Street ramp was initially looked at to determine if enough traffic could be diverted off of SR 378 to improve congestion. Several options were evaluated to improve the Spring Street ramp. However, based on a preliminary traffic analysis, it is not anticipated that opening and improving the Spring Street ramp for use by southbound 378 traffic would divert a sufficient number of vehicles to result in any meaningful improvement to traffic flow. We refer to these improvements as add-ons or a la carte, as they generally can be added to any of the alternatives under consideration. Early on, the city of Bethlehem requested that PennDOT investigate improvements to allow vehicles to turn onto the 2nd Street ramp from 2nd Street. Currently, vehicles who wish to get to 378 from this area must do so by using West 3rd Street. During the alternatives analysis, improvements to this connection were evaluated. Important constraints to consider at this location include the elevation difference between 2nd Street and the 2nd Street ramp, special protected grant land located along Riverside Drive, the historic Lehigh Valley Railroad Station property located between Riverside Drive and the railroad, and the parking area used for St. Luke's building. Based on a preliminary analysis conducted alongside the alternatives analysis, the intersection of 2nd Street and Riverside Drive can be modified to allow movements onto the 2nd Street ramp. This can be accomplished with minimal impacts to surrounding properties. However, it would require that the entrance and parking area of the St. Luke's building be converted into a one-way entrance. Vehicles using this facility would follow the yellow dashed line shown on this slide around and back to 2nd Street using Union Station Place. We continue to look at this access to see if more complete access can be provided. This concept will continue to be evaluated as design progresses and coordination with the City of Bethlehem continues. With the alternatives developed and a detailed analysis conducted, we can now compare how each alternative meets the needs of the project. As seen in the table on this slide, the no-build and rehabilitation alternatives do not meet the needs of the project, and so they are dismissed from further consideration. This leaves alternative 3B and 5B. Both alternative 3B and 5B meet the minimum base needs of the project, with 5B resulting in improvements to the safety need given the additional lane and shoulder width which can be provided in comparison to 3B. Alternative 5B also results in improved connectivity for bicyclists compared to 3B. Since both of these alternatives meet the needs of the project, we now look at other factors to consider, including the project goals. Comparing the anticipated impact to traffic of both 3B and 5B, we see that alternative 3B will require temporary single-lane closures during nights and weekends in order to facilitate rehabilitation activities on the existing bridge. The connection of the new structure to the existing bridge would necessitate traffic to be reduced to one southbound and one northbound travel lane. The construction of alternative 5B in comparison would first include construction of a new parallel structure. It is anticipated that this construction could take place while maintaining 4 lanes of traffic on the existing bridge. Connecting the new parallel structure back into the Main Street ramp would necessitate a short duration complete closure of the Main Street ramp estimated to last between 1 to 2 weeks. Similar to alternative 3B, rehabilitation of the roadway across the existing bridge would require traffic to be reduced to a single northbound and southbound lane, which would be maintained on the new parallel structure. What sets alternative 5B apart from 3B is a substantial increase in impacts to historic and environmental resources as well as private property. Compared with 3B, 5B would result in the removal of the Fritsch sign and silos, impact the central Bethlehem and Fountain Hill historic districts, and have a substantially larger visual impact on the existing hill-to-hill bridge. Finally, although not a primary driver for the selection of alternative, it is helpful to look at the anticipated cost of each of these alternatives. As you can see, our preliminary estimates indicate that alternative 5B at $101 million will cost almost double the anticipated cost of 3B, which is estimated to cost approximately $56 million. Either one of these alternatives is a significant investment in this critical piece of infrastructure. In summary, alternatives 3B and 5B both achieve the minimum base project needs, with 5B showing an improvement to overall safety by providing wider travel lanes and shoulders and greater improvement to bicycle connectivity. This comes at a significant increase in impacts to the surrounding resources and private property, and at nearly double the cost of alternative 3B. 3B, on the other hand, realizes the project needs through specific targeting of improvements to where they are most needed on the south side of the structure while minimizing the overall impact to surrounding resources and at about half the cost of 5B. For these reasons, the department is proposing to progress alternative 3B into preliminary engineering. With a preferred alternative identified, the next phase of the project will progress alternative 3B through preliminary engineering, final design, and ultimately to construction. Soliciting public input now and throughout the design phase will continue. In preliminary engineering, the initial engineering and environmental analyses and design will be completed for the proposed improvements. Moving into final design, expected to start in 2023, final engineering studies and design will be completed. Coordination with utilities will be finalized, permits applied for and acquired, and property impacts will be assessed and owners coordinated with. Final design will develop the project's final plans, specifications, and engineer's estimate, which will be used to solicit bids from the contracting community for the construction of these improvements. Given the current schedule, it is anticipated that construction will begin in 2025 and be substantially complete by 2027. During the preliminary and final design phase of the project, PennDOT will continue the conversation with the community and project stakeholders through additional public and stakeholder meetings. Hopefully, the next time we meet to discuss this project, it will be in person. This concludes the virtual public meeting. Thank you again for your attendance and interest in this transportation improvement project. We look forward to continuing this conversation in the future. Please use the comment form located to the right of this video to provide feedback on this presentation and the project. If you have additional questions related to the project, please also feel free to contact the Consultant Project Manager Brian Tellis at c-bteles@pa.gov.